Today, we are going to talk about multiplying fractions by whole numbers using repeated addition. We're going to think back to yesterday's lesson or the last activity that we did. We're going to think about how we drew a picture to represent each part of the fraction. So we had 6 times 1/5, and we drew 1/5 6 times. We knew that it was 1/5 because one piece was colored in out of the 1, 2, 3, 4, 5 pieces. Then we counted all the pieces together. So we said 1/5, 2/5, 3/5, 4/5, 5/5, and 6/5. We also did it where we drew all of the pieces of the fraction on one single bar until we ran out of room and then did another one. Again, this is broken into fifths. 1, 2, 3, 4, 5. This second bar is also broken into fifths because we have not changed the denominator. Then we went back again and we counted each piece. 1/5, 2/5, 3/5, 4/5, 5/5. When we got to 5/5, sorry about that, we remembered that 5/5 is the same as one whole. We can see it right here. We needed one more fifth because we needed 6. So we have 6/5. And when we look at these two bars together, we can see that this is one whole and 1/5. So we would say 6/5 or 1 and 1/5 are equivalent. Today, before we get started on repeated addition, we're going to talk about 2 new vocabulary words. You might have remembered this from last year. Fractions that are greater than 1. If a fraction is greater than 1 whole, then we can have an improper fraction or we can write it as a mixed number. In the world that we live in, we usually use mixed numbers, but we can also write it as an improper fraction. So an improper fraction is a fraction whose numerator, that top number, is greater than the denominator. So this example here is 7/3. Okay? I wrote it in words, how we would read it, 7/3, but this is how we would write it in numbers. We think about what 7/3 are. It's 3/3 plus 3/3, which is 6/3, plus one more third. And we can see it here using this visual. We can also write fractions greater than 1 as a mixed number. So that's a whole number and a fraction. An example is 2 and 1/3. This is how we would read it. This is how we would write it. Notice that right here there's a space in between the number 2 and 1/3. Otherwise, it would come up as 21/3, and that's not what we're showing. 2 and 1/3, we all know 1 plus 1 more would give us 2, and then 1/3. If you look at these two, we know that 7/3 and 2 and 1/3 are equivalent. We can see it right from their pictures. Okay? Today, we're going to use repeated addition to help us solve multiplication problems involving fractions. So we got to think to ourselves, what is repeated addition? Repeated addition is when you add the same number multiple times. So an example that we have used a lot of times in class would be 5 plus 5 plus 5, which gives us 15. And we know, because we've been practicing our multiplication, that this is the same as 3 times 5, right? We have 3 5s. We can also use it when we're talking about fractions. So if we have 1/2 plus 1/2 plus 1/2, that could be the same as 3 times 1/2. Again, here I have an improper fraction, and then I have a mixed number. Let's try some. So I have 4 times 1/3. If we create 1/3 4 times, 1, 2, 3, 4. What I like to do, and I know a lot of students in class like to do from our number talks, is add 2 numbers together and then add the other 2 and then combine them further. So that's what I did here. I said 1/3 plus 1/3 is 2/3. And then again, I did 1/3 plus 1/3 to get 2/3. My answer here is 4/3. 4/3 is an improper fraction because the numerator, 4, is bigger than the denominator, 3. What does 4/3 really mean, though? If you're talking to someone in the real world about how much you have left of your pizza pie or of your cookie or of a brownie, you wouldn't say you have 4/3 left. You would probably use an improper fraction. So let's look at how we can change that. 4/3 means that we have 3/3 plus 1/3, right? We know 3 plus 1 would give us 4. If we look at it as a picture, we can see 1/3, 2/3, 3/4, 4/3. If we look at this and think of this as one whole, we have one whole and 1/3. So we would say that 4/3 is the same as 1 and 1/3. Again, notice that I have a space here so that these two numbers are not together. Okay, let's try another one. 5 times 2/3. Again, what I did is I added 2/3 5 times. 1, 2, 3, 4, 5. Again, what I did is I added these two together first. I added these two and then this one. So 2/3 plus 2/3 would give me 4/3. 2/3 plus 2/3 again is again 4/3. And then we have one more 2/3, so I just brought it down. I know 4/3 plus 4/3 will give me 8/3. And again, I brought my 2/3 down, giving me my answer of 10/3. 10/3 is an improper fraction. So what does it really mean? Before I say anything, you can pause the video here and try to explain it out loud, or you can listen along. 10/3 means that you have 3/3 plus 3/3 plus 3/3 plus 1/3. Let's check my math on that. 3/3 plus 3/3 would give me 6/3, plus 3 more thirds, 9/3, plus 1 more third. Let's look at it as a picture. 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3. When we look at this, what do you think we can write the mixed number as? Remember, a mixed number is a whole number and a fraction. If you said 3 and 1/3, you would be correct. 10/3 is the same as 3 and 1/3. Today you're going to get a chance to try this out. You can use the improper fraction, 10/3, or the mixed number, 3 and 1/3. If you think it's really easy to write it as an improper fraction, I'm going to challenge you to change it to a mixed number. You can do that by drawing a picture or thinking about how many you need to make a whole. We know that a whole always has the same numerator and the denominator, okay? Today, it's going to be, you're going to get the choice, which one you want to do, but in the future, we're going to be moving towards using those mixed numbers because that's what we normally use in the real world. You can watch this video again, you can pause it and rewind it. You can even go back to that slide that talks about the two different types of fractions greater than 1 if that's going to help you. Let me know if you need any other help.